Hey everyone, my name is Patrick Akil, and for today's episode, we talk about creating your own programming language. My guest Felienne Hermans talks about Hedy, the language she created to teach kids how to program. She mainly does that over at the High School of Rotterdam, Lyceum Kralingen, and she also teaches at the University of Leiden. Hedy is now used all over the world, and it's an amazing journey of how she created it and where it's going. Don't forget to like and subscribe on YouTube and follow us on your favorite podcast platform. Enjoy!
Welcome to Beyond Coding, a dive into the world of successful people in IT. From your sponsors, Zebia, creating digital leaders. Here's your host, Patrick Akil.
Hey, Felienne. How's it going?
Good. How are you?
I'm good as well. It's already pretty late in the afternoon. We got a whole setup for the remote recording here. But I'm happy to have you on. You're very busy and hard to get a hold of, basically.
Yes, thanks for being so patient with the planning.
Yeah, no worries. We plan ahead, which is nice in this way as well. I invited you to talk about programming languages, or more specifically, creating your own, because I know you've created your own programming language, but I don't know why people do that. There's a lot of them out there. And they keep popping up, basically. I mean, I've seen Lua and Julia as more of the newer flavors. But I don't know why. Why did you decide to kind of start your own programming language in the first place?
Yeah, so I don't know. I can't speak for other people why they do it, but
Yeah.
I think many people do it for the reason I did it, and that's to solve a problem I had myself.
Yeah.
I think that is a reason that many people make a programming language, that there isn't something that exactly fits their needs.
Yeah.
And they have the skills to build something that fits their needs better. That's definitely what happened in my case.
Yeah. And what was the problem you were trying to solve then?
So the problem that we had is that I started to teach in a high school a few years ago, in a Dutch high school, and then the youngest kids in Dutch high school, they're 12.
Yeah.
And we thought, they can do Python because Dutch teenagers, they know English and they have enough keyboard and typing skills, so it should be okay to do Python.
Yeah.
It's a friendly syntax, right? It's a friendly language for beginners. But then we found that for some kids it was totally okay. Some kids might already have a bit of experience with programming, or they're just very excited. But for some kids, Python was too hard. And I think this was because of the syntax, because there are a lot of things that can trip you up, right? Even this very simple program, just printing hello everyone. You have to do print, and it cannot start with a capital letter, and it cannot be a D at the end of print, because then Python crashes. You have to use round brackets. You have to use quotation marks. If you want to use a variable, right? Like name is Patrick, and then print hello name, and then hello has to be in quotes, but name has to not be in quotes. So there's all of these subtle things that can go wrong, and some kids were just only struggling with that syntax. And then that prevented them, A, from understanding the concepts, like what is the concept of a variable, and B, it also prevented them from having fun. They started to get really frustrated, like, programming is not for me. I will definitely not choose this as an elective because it's too hard and it's too tricky. So I thought, well, what can we do? Clearly there is a solution, and that's block-based languages, like Scratch, right? Visual languages, you click the blocks together, you have no syntax, no syntax errors directly. So this is nice, but then, it looks a bit childish, and especially in high school, kids want to do grown-up stuff because they're already old, right? And they're almost adults, they think.
Yeah.
So they were just not so excited about the kid stuff. So then I thought, well, maybe what we can do is we can make a programming language that does things step by step.
Okay.
And already conceptually, many teachers do this, right? You don't teach functions in lesson 1. You do say first you do printing, and then maybe variables, and then conditions. But then you do always have to use the full syntax of Python. That's just what you do. So then I thought, well, I can just make a baby Python. Don't tell my students I call it baby Python, but that is what it is. We make a baby Python, whereas in the first level, you don't need to use round brackets around print, and you don't need to use quotes for strings. You can just do print, hello everyone, hello Xavier, and then it just prints that without any syntax, so to say. And then gradually, every level we add a concept. So then first we add a variable, but then we do not distinguish between strings and variable names. You can just say name is Patrick, print hello name, and then it just works. You don't have to make a difference. And then, slowly we add the concepts until at the end, level 18, you are actually doing a subset of Python.
Nice. I don't know how it is to get taught a language, let alone teach it to someone else on that level, right? If they're 12 to kind of 16 years old, your brain already has a lot it's getting taught, right? You have the basic kind of electives that you have. And then programming is very specific, as you mentioned it as well. I think I got taught Python initially, and I didn't really mind the syntax, right? I could just accept this is the way it is, even though I don't really understand why that is. But maybe at the age of 12 to 16, you ask more questions. I don't know how that would go.
Yeah, and so we found that it really differed. So for some kids, it was totally okay, right? They could start with Python fine.
Yeah.
But for some kids, indeed, for various reasons, it was hard. Some were already a bit insecure.
Yeah.
Sadly, typically girls are a bit less, they just have less self-confidence about programming, maybe because people tell them to their face it's not for them.
Yeah.
So there was that category. And also, indeed, people were like, so teacher, why do I have to put a round bracket there, right?
Yeah.
And you cannot answer that question at the level where they are.
Exactly.
Right? Because then you have to explain, well, this is actually a function. Like the f of n is n squared in math, but then there can be multiple parameters, right? You can explain it, but then you have to first explain many other things.
Yeah.
And then, of course, you say something like, well, child, just put it there. Don't think about it, just do it, which is, as a teacher, it's an unsatisfactory answer, right? I don't like to say, just because I tell you to.
Exactly. Yeah, that makes sense. Man, you would have to explain a lot of stuff just to get the basics in if they would really drill down and ask those questions. So
yeah, exactly, and that definitely happens. And then just it's not there's not a good solution there, because you can say something like, well, imagine that this syntax element was not there.
Yeah.
That would be confusing. Right? They cannot imagine a language that doesn't have that. They can hardly imagine Python.
Exactly. Yeah. So what is the end result you have now? Is it similar to kind of pseudocode? I mean, pseudocode's kind of different for a lot of people anyways.
Yeah, so definitely level 1 sort of looks like pseudocode. Level 1, it's literally the word print.
Yeah.
And then whatever you put behind print, that is what's printed.
Yeah.
And then you also have ask, which is secretly input. So you can get a pop-up, like an alert in JavaScript. And then also you can ask the user for input, so you can make something that's a little bit interactive.
Yeah.
So it definitely has this pseudocode feel, because it doesn't have quotes and commas and brackets, but it does run, right? Secretly, it transpiles already to Python.
Yeah.
So it's not pseudocode in the sense that it doesn't run.
Yeah, that's really cool that it's kind of a screen in front of Python, right? To make it easier for you to input stuff, and it transpiles then to the actual language. So probably gradually you can introduce more concepts as well eventually.
Yes. Yeah. So for example, in level 2, we introduce variables.
Yeah.
And then there are variables. So then you can set a variable to a certain value, and then you can use it, but then it's just string values. Then there's no calculation or something yet.
Yeah.
And then we add lists, and then we add conditions, and then we add data types and loops. So all these things that you would traditionally teach in a course, they also are part of our trajectory.
Yeah. What was the effect on the class after you had implemented it? I don't know the time frame here either. How long have you been teaching with this new language then?
So this is the second school year that we're teaching with this language, but we have 3 new groups in a school year. So we are already at we had 2 groups last school year, and now we've had 2, 3. So this is the 6th and 7th group in our school are starting next week. So we've done a bunch of generations, so to say. We never did Python and also Hedy with one generation, because of course, if they're already doing Python, then we can't say, oh, stop, this is too hard, now we're switching. So we've only had fresh bunches. But it has been really interesting. And I think the best feedback that we got from the teacher in that school, in our school, is that he said, when we use Python, only some kids were having a good time, and only some kids were learning. And now with Hedy, all kids learn some concepts. Still, you have kids that go quicker and they know more and they advance maybe to a higher level. But at least now it feels like everyone has a fair shot. Everyone is enjoying themselves. And we did another experiment with specifically only with girls,
Yeah.
and a female teacher. And that female teacher also said, like, oh, wow, it's like this is made for girls. Well, it's not made for girls specifically.
Yeah.
But we just know from research that sadly girls have this, they just have lower self-confidence. So if you break it up into really small steps and they succeed in the small steps, then
Yeah.
the girls go like, oh, I can do this. Oh, this is doable. And then slowly add a little bit more. And then they are also sort of sucked into how fun programming can be without, we push a bit of the frustration backwards. I think that's one of the things we do.
I love hearing that, just getting all the kids on kind of the same base level, right? And that gradual approach is not there, or it's harder in a specific programming language. You get confronted with a lot more first. And then gradually.
Yes, definitely.
Yeah.
So, and also like one of the, well, this isn't the explicit goal, but this is also what happens. It's also a leveling device. So what you can have in a high school, but also in a university, is that, 2 or 3 kids, they already know a lot of programming.
Yeah.
When I was in university, I was that annoying student.
Oh, really?
Like, oh, I already know everything. Yeah, look at this ginormous program I made, right? And this is also, well, not useful for them because they already know this, but also it can be very detrimental to the rest of the class, where kids that have no experience are like, well, this guy already, usually it's a guy, this guy already has 500 lines of Python in 1 week, right? So I will never get to that level. So the nice thing also is this level, a teacher can block levels. A teacher can say you can only go to level 3, and after that it's just closed. If you're there, go read a book, go read a Donald Duck, right? Stop programming. So it also makes sure that the quicker kids, which you could say, that's not where you're necessarily most concerned about, those kids that can already do programming in a programming class, because it's also a break for them. It's like, well, if you can already do these things, congratulations. There's nothing to learn for you now. So it's very much a leveling device also.
Yeah, awesome. Let's dive into kind of how you started creating this programming language. Because if someone said, Patrick, create your own programming language, I would have to Google a lot of stuff initially, because I have no clue how you would start it. So you decided to start this to solve the problem that you had. How did you start, and how did you go about doing it?
Well, I also did have to Google a few things, but the benefit was that I had a lot of training already. So I had experience actually in building developer tools. My PhD thesis was about spreadsheets, and for my thesis, I built a spreadsheet IDE. So something that can do, for example, smell detection on spreadsheets. And as part of that, we had to build a parser for spreadsheet formulas, because if you want to detect clone detection, for example, like, is this formula used in many different places? And we also build a refactoring tool for spreadsheet formulas. So you can imagine if you have to refactor something, you have to first parse it. You have to understand what does this formula do before you can process it. So I had some experience actually writing grammars and writing parsers and that type of stuff. And also when I was in university, even before my PhD, I really, really very much like programming language design courses. I took like 5 compiler courses as electives. I don't remember why I took these things, but I thought it was just really interesting to build programming. So I did have some experience and some knowledge, even though, of course, I also had to build a bunch of things. Luckily, though, I didn't have to build everything from the start, because the first version was very much 3 other open source projects stringed together with a little bit of duct tape, and getting it done. So one of the things we use is a framework called Lark. This is a grammar and parser framework for Python. So you can type a grammar, and a grammar is what your programming language looks like. So you can imagine for our level 1 of Hedy, the grammar says, well, first there is the word print, and then there's whatever random text you want. This is a rule that exists. And here's another rule that exists. You can have ask. Ask also has the word ask, and then whatever you want. And then what does a Hedy program look like? Well, it's either ask or print or echo. This is our third command. Or it is an error program. Any other thing that doesn't look like these 3 things, it is an error program. So you can define that in Lark, and then Lark can just transform any text you give Lark to a parse tree, to the structure. And then that parse tree then can be interpreted. So I look at the tree and I know, oh, this is print. And then what I do now to transpile this to Python, to make Python out of this, conceptually, I say, okay, well, I again put print there, and then I put brackets around it and quotes around it, and then now it's a Python program.
Interesting.
And then comes the other open source project that we use is called Sculpt, because Hedy is a browser-based language.
Yeah.
So I had Python. Okay, now what, right? Now I have a Python program. Okay, I can run this on the command line, but a 12-year-old is not going to use the command line.
Exactly.
And also in many schools, teachers can't even install an IDE.
Yeah.
They have to do it in the browser because they don't get access to the computer. Like I cannot even install Visual Studio Code on the computers in my own computer room in the school that I work in.
Yeah.
So yeah, now I have this Python program. Now what? So Sculpt is a nice re-implementation of Python and JavaScript. So then you have a Python program, and Sculpt just runs this for you in the browser in JavaScript. So these two things combined, and a bit of Google and a bit of shoestringing everything together. This was version 1,
Yeah.
and then I made a prototype, and it sort of worked.
Yeah. And then the prototype, how did you kind of test and make it better? Basically, did you already experiment on your kids? Man, that sounds bad. Experiment. Yeah. Yeah, exactly.
Yes. So yes.
Yeah.
No, this is what we did. So we did 2 things actually. Interestingly enough, when I was programming this was in the Christmas 2019. Little did we know of what would be coming.
Yeah.
So when my first prototype was ready, this was February 2020.
Oh yeah.
And then I was supposed to go to Norway actually to speak at a conference where I would launch Hedy.
Yeah.
We would put it out there, but then this conference was cancelled sadly, and then COVID happened. So what we did then, I did the work. So it's like, wow, okay, this exists. Maybe when the schools are closing and you're sitting at home and you're bored and your child is bored, you can do some programming with this free thing that we made.
Yeah.
So the university made a really nice press release saying, well, if you are at home with your child and your child is bored and you want to do something educational, maybe you could try this. So that already gave us a lot of usage data. So we could already see what error messages are commonly used. Then we had no user accounts. We didn't know what type of kids were making the programs, but at least we could see what type of errors are common and do we understand this error. So that led to a lot of improvements. And then, then we had lessons. They were online lessons, of course, but then we started to do lessons online in our own school for high schoolers, exactly of the group, the brugklassers, the first year high school students that we aimed for. Well, we did online lessons and online observations, and we had them fill out the survey online to gain some understanding of what worked and what didn't work.
That is such a cool and kind of practical approach. Just putting it out there and I mean, right as you would another product, right? If a company creates a product, you get it into the hands of the user and you learn from them actually using it, getting that feedback and then implementing those changes.
Absolutely. And I think if it would have been not COVID, then we would have done it smaller scale.
Yeah.
We would have first done 1 or 2 classes and iron out the biggest bugs. But then it was very clear at that point in time that wasn't going to happen until a very long time. Actually, it wasn't until the summer of 2021 that I observed with my own eyes in front of me in the same room a child using Hedy.
Yeah.
This is when already 1 million Hedy programs had been created, because only then again we could do face-to-face stuff with children. That wasn't what we had wanted, of course, but it ultimately did work quite well. We learned a lot from the data gathering as well, and after a while we have this now where you create a user account. You can, if you want to, you don't have to, but you can create an account, and then we ask what is your gender, where are you from, what is your year of birth. Then we gather data that's a little bit more precise, so we know what younger kids struggle with, what older kids struggle with, at least if you give us permission to use your data for that purpose.
Yeah. Could other schools also use and implement Hedy in their own kind of educational system?
So they can use it for sure, and they do use it also. There are dozens of schools in the Netherlands and even more outside of the Netherlands that actually use Hedy already.
Awesome.
But then they do use the web version, like the version that we give to them.
Yeah.
In principle, of course, if you want to make your own changes, suppose you want to merge 2 levels or swap 2 levels. If you're a computer science teacher and you have the skill, it is open source. You can fork the repo, you can run it on your own local machine inside the school.
Yeah.
That is absolutely possible, allowed, and I wouldn't say encouraged, because I would rather have people use our trajectory and give us feedback if it doesn't work. But it's definitely possible. Yeah,
Yeah,
our open source license allows for that type of use.
that's awesome. And you mentioned immediately it's open source, so I want to zoom in on that. You're not. Are you the only contributor? I hope not.
No, there are
Yeah.
many countries. That would be very impressive, because in the meantime now, Hedy is available in 18 different languages,
Exactly.
including Hungarian, Czech, Chinese, Arabic,
Yeah.
Hindi, Bengali. So no, luckily we have many open source contributors, and of different flavors. So some people are translators, and
Yeah.
they just translate content. They translate keywords and stuff related to the language.
Yeah.
Some of them are school teachers. They don't even are necessarily programmers, of course. But also we have some contributors around the world that are helping us, just to fix bugs, add features, sometimes discuss implementations. Just the teachers. We have in our team. We have an elementary school teacher in the Netherlands.
Yeah.
She doesn't necessarily contribute code, but she contributes content. She writes lessons. And she also participates in discussions. We say, "Oh, what do you think of this feature?" She says, "No, I think that's a bit too complicated. Or couldn't you do this and this?" And she makes really nice mock-ups.
Yeah.
She says, "Oh, why don't you make this?" And then she puts it in Photoshop, and we're like, "Oh, that's great. We can make that." So those type of contributions, of course, are also very, very welcome to the team.
Yeah, that sounds so cool. Did you imagine it going this direction when you created it? Because it was very much
No.
targeted to solve a specific problem, right? And it's probably solved that, and it's solving different problems now as well.
It's also creating different problems now, because now I have to maintain the open source project.
Yeah.
I think, in all honesty, if I would have known that all of this would have happened, I don't know if I would have wanted to start, because
Okay.
I just made this prototype. It was very good, right? It was just everything meshed together.
Yeah.
And now we have to do maintenance, of course. Now it's big, and some of the stuff we have rewritten,
Yeah.
and we have some other rewrites planned, just because we didn't anticipate scale. Like a funny story is, one of our biggest initial users was a boot camp in South Africa.
Okay.
They used to do Python, and they had the same problem of feeling that for some of their participants, Python was too hard, and they saw it on Twitter, and they maybe overestimated our professionality, because it looks really nice, but in the back end, it wasn't really built for scale or anything. And they had 600 students join in one day.
Oh wow.
Poof, our free Heroku plan that we
Yeah.
ran at that point in time. It was like,
Yeah.
so yeah, it was. They sent me a really nice email. They're like, "Yeah, we couldn't help but notice everything is broken."
Oops. Yeah.
So yeah, these things, if you, it sort of, maybe you get if you really want to build something for production,
Yeah.
maybe I think I would have gotten a bit of like analysis paralysis, like, oh no, what is the right choice for this? And how
Yeah.
do we make a skill for 100 users? And then if you have to think about that from the beginning, then maybe you never got something finished. So I'm happy I really started small and naively. And then of course, well, an obvious solution was just to throw more money at Heroku initially, right?
Yeah.
We just bought a more expensive plan, which will solve the problem for a while. And then we're like, okay, what happens if 100 users log in at the same time? And what are the optimizations we can make? And then then you have to do some rewriting. But if I would have done all those things in the beginning, then maybe that would have never been a prototype.
Yeah. I think it makes sense. I mean, I have a hard time saying what I would do, but I like your approach in starting really small, right? And when there's a new challenge, when the challenge is scale, you fix the scale basically. Or when the challenge is, well, it doesn't actually work, there's a critical bug, you fix that, and you look just enough forward and not too far ahead in the future. And you just keep improving.
I think that
what you
really
have.
makes sense, because also in the beginning, I didn't know if it was going to solve my problem, right?
Yeah.
And there were two different questions that I didn't have the answer to. One question I really just didn't have the answer to was, can I build this technically?
Yeah.
Because there are very, very interesting challenges that you run into, because parser frameworks, they are meant for one language. They are meant for Java or Python. Sometimes they can handle two languages, something like C# and Link, right? Link is
Sure.
sort of a sub-language. Or some parsers, they can do Java, and then you are allowed to embed SQL, and you don't have to put it in the string. You can just type SQL, and then it knows what you want.
Yeah.
So there are some of these parsers that handle two languages, but then having different levels of languages.
Yeah.
So initially just build separate languages, like level 1 and level 2 were unrelated, but of course they're not unrelated. You want to do something with the one language to the other language. So one question was, can I build this? Right? Is this a reasonable thing to do?
Yeah.
Can I be part of framework so much that they do this thing? That was one question that I just didn't know what would happen.
Yeah.
Another question was, and then you have this language, how does it feel? Firstly, to me, like, does it feel like a real language? And then you want to try it with kids. And all of those things also could have failed, right? Maybe it was too hard and we would have gotten too many error messages, or maybe kids would reject it philosophically. And some kids do still, like some kids also reject Scratch. They say this is a baby language.
Yeah.
Right. We are adults. We want to have a real language. Of course, we can sometimes you argument with these kids, right? Yeah, because level 18 is actual Python, and some of them are like, okay, that counts. But some of them reject this. They say, no, I want to have a real full language. I don't want these baby training reels.
Yeah.
And so these are all things that really we just didn't know at the beginning. Can we build this? And will kids actually like it?
Yeah.
And then there is, of course, still the question, like, does it help? And do they learn something? But if kids don't buy it that it works, if they don't like what the look and feel is, then it's not going to happen.
Yeah, it's interesting that you mentioned that, because that would have never been one of the things I would think of, that kids would actually reject it and say, these are training wheels and I want the real thing, basically. Yeah.
Yes, no, that's definitely a thing. And we specifically saw that in Scratch, that after a while, 11, 12-year-olds, when they start to go to the end of elementary school, the beginning of high school, they're like, no, I don't want to have a toy language. It looks very toy.
Toy language.
No, this is what my little baby brother in group 6 in the Netherlands, right? In 2 or 3 years younger than me, they use this. I want to use something that's more age appropriate, that really fits early puberty, when you want to do stuff that is authentic, and you want to do stuff that is adult. And also another dimension is, some kids want to get into programming, not because they like programming, but because they realize it's a good career. Right? They want to become programmers because they can make 100,000 euros at Google, which I think is a valid reason to want to become a programmer. If that is your goal, not necessarily learning concepts, but really having an employable skill, then Python is what you want, right? Or JavaScript or Java or C or C# for Unity, for example. Then something that looks like a toy, it doesn't feel like it meets your goal.
Yeah.
And then you get, again, in this discussion, you can convince a kid. You can say, well, but this is actually like the thing you will use, and the thing you learn now, it will be useful later. But this is a bit like the round brackets. You have to sort of tell them, trust me, this will be fine.
Yeah.
Having something where they immediately see that it looks like something that can make them money, if that's their goal, that of course makes sense.
Yeah. And it goes back to, I think, how other concepts are taught, because stuff like math, right, it's very theoretical. You can think, well, you're going to benefit from it in the future, right? It's going to hone your thinking process to some degree, or you're going to see some examples which make sense in the real world. But programming languages are the real deal, right? If you actually teach someone Python, they could get a job if they're good enough, basically, if they spend a lot of time for themselves. So this basically goes back and goes more towards the theoretical of the why does it do what it actually does, and how can you make it do the next thing, basically. Teaching them more of an introduction towards programming, and getting them ready for the real deal.
Yes. Yeah, and that is a trade-off, of course, because especially if a kid is really very much interested in the real deal, but this is too hard, right? Yeah. I remember when I was 15, I wanted to learn C++. I could already do BASIC and a bit of Pascal, but I sort of had the same struggle. You know, BASIC and Pascal, they were not really serious language. Even when I was a teenager, already Pascal was sort of outdated and not what people used. What people use in industry was C++. And then you pick up a C++ book and you're like,
oh yeah, I get started.
Never mind. I'll go beep, beep, beep. I'll go back to Pascal, this is literally what I did. And I just did Pascal for a very long time after that, because it was just too hard and too overwhelming. So this initial interest, it gets you somewhere, but it isn't enough. It wasn't enough in my case, and my initial interest was quite big. It wasn't enough to get over that hurdle.
Yeah. Let's step back, because you mentioned you went from kind of how I see it as an exploration phase, right? Can I actually do this with the thoughts that are in my head? Can I make this programming language in the first place? And will it solve the problem that I have? To the actual reality that you are in now, right? It's actually being used in a lot of schools across 18 different languages, which is ridiculous. But you're also kind of, the maintainer of this language now, which is a role kind of you've been put into, or kind of the role you created for yourself, which is kind of weird to say. But how do you see that for yourself? Because I don't think it's going to go away, or I don't know how it would go away.
Well, sometimes I fantasize about deleting the whole repository and changing my email address.
Yeah, and going off the grid.
Yeah. But I guess going off the grid. I guess other than that, no, it is true. It doesn't go away, and now more and more schools are using it, and we have repeat customers.
Oh, your audio went away for a second.
Weird. And now they're coming back for a second group.
Yeah. I think Feliene's audio keeps dropping. Yeah. I think the Zencastr audio will fix it though. I think we're back. Are you still there, Felienne?
I'm still there. Yes.
Okay, yeah. You dropped off. You dropped off twice for me. No worries. Keep going.
Okay. So we have returning customers now, which is really, really nice. We had a school last year that they used Hedy when it was really still in its infancy, and now this year again they're registering new classes. So that's both a compliment, but also that means that they are putting this into their lesson plan, right? They have this lesson plan where they say, well, we do Scratch, and then we do Hedy, and then we do Python. So you have a responsibility sort of to keep it up and running.
Exactly.
So yeah, that is hard, and sometimes you have to make really, really tough decisions where there isn't a clear good answer. Like just an example, we are translating now also the keywords to different languages. So you can program in Dutch if you want to. You can say vraag something instead of ask something.
Nice.
And also in Spanish. And I don't really speak Spanish. So some of the Spanish contributors, they get into a discussion about what is the right translation for print. I had never really thought about that, but the word print in English, of course, is both imperative and also infinitive. Yeah. It is imperative, like you have to print something, but it's also the full word print, which in Dutch would be printen. So they say, no, we don't want to have the imperative form, print something. What we want to say is printen in Dutch something.
Yeah.
We think that form fits best. It's like the computer now goes to print something rather than saying, you computer, you have to print something, as in giving an order. So yeah, this discussion ensues. And then I have to make a decision, which do we pick? And I don't even speak that language.
Yeah.
So that is indeed a really interesting role where you consistently have to make all sorts of decisions about the language, but also decisions about the UI. Today I was chatting with a teacher and they said, well, there's this option that you can switch between different languages.
Yeah.
This is nice that you can do that, but also it's an extra button and it makes the UI fuller, so it can be distracting for kids. Yes, this is a good point. So do we put the button there? Do we keep the button? Do we make it a setting somewhere to switch on and off the button? There's this continuously, like, consistent barrage of questions that if you're the benevolent dictator that I guess I am, I have to make all these decisions. And of course we have discussions with contributors. I ask teachers for their opinions, but ultimately it is me who makes these decisions.
Yeah. Do you know how other languages have handled that? Some languages are just backed by companies and you have a team and a board and a whole shebang behind it. But some languages are still open sourced, right? Even though off the top of my head, I wouldn't know which ones those are.
Yeah, so for example, Python for a very, very long time, the creator of Python, Guido van Rossum, he was also what he calls the benevolent dictator. So he was the sole person making the changes or making the decisions, at least. Of course, also there was a mailing list and he very much listens to the voice of the community, but he was the one making the decisions. This is a model that some programming languages have. And sort of on the other end of the spectrum, you have JavaScript. There's a JavaScript committee, TC39, that I'm also part of, that makes decisions. And this TC39, it has like 600 members.
Exactly.
So if a new proposal comes, and most of the members are backed by organizations. So there's someone there, like from Google and Facebook and Microsoft, the big companies participate in this committee. And then also some universities, like my university, also participates as an organization. That is a profoundly different system, where if you want to have a new feature, you make a proposal to the committee and it is discussed, and you have this, well, it's really bureaucracy in a committee where, this proposal is now in stage 1, and then we vote to move this proposal to stage 2. And that means someone can make a demo implementation, someone will make an implementation, talk about how it is implemented. Because sometimes, and this is really interesting, sometimes people have an idea and they start implementing it, and then it doesn't feel well. It is too hard. It's harder than they thought.
Yeah.
Or they implement the demo and they start playing with their own language feature, and they're like,
doesn't feel
so
right.
good. This doesn't feel right for whatever reason. So there's various different models that programming languages have. Either they are indeed open source, but even languages that are open source, they can still have a committee that makes all the decisions, or a single person. Or a single person that works for a company.
Yeah. I think I don't know if it's actually true, but with the committee, it sounds more, manageable, I guess, more maintainable maybe, because it's with a group, right? It's like democracy. Except you go through a lot more stages to get your changes in, basically. And if you're the single person...
I think everything has pros and cons.
Yeah.
I think the nice thing about being one maintainer, and I don't want to say this is necessarily true for Hedy, but I think it's quite true for Python, is that you can make sure that what the language is doing, that in all decisions, this philosophy is there. And I think Guido, the creator of Python, he made many really good decisions. And he also talks about this sometimes, that he calls this the Harry Potter language design philosophy, which is really, really nice. Because in Harry Potter, you have all these things that happen in book 1, and then you're in book 6, and suddenly they make sense, right? So the creator of Harry Potter sort of uses stuff that she puts in there, and she's like, oh, but I actually did that because this reason.
Yeah.
And so he says it's sort of intuition-driven programming language design, where you make some choices and only later you realize why these choices were the good choices. If you have this one person using basically their intuition on everything, you do get a language that's coherent and feels like one thing.
Yeah.
Whereas I think a risk with the committee, and again, I'm not necessarily saying this is happening with JavaScript, but if you have a committee, you can get this Hansel and Gretel house, right? With here's a pancake
monstrosity,
and there's another cookie. There's a monstrosity of stuff.
Yeah.
And everyone likes their own little window or door, or their own little shed that they put that's made out of chocolate in the back.
Yeah.
They all like their things, but as a whole, maybe there are some contradictions. And I guess in the case of JavaScript, it is somewhat true that there are some edge cases where you would expect the one thing, maybe based on some features that do exist in the language, but then in this specific case, there is slightly different or very different behavior. This is a risk. And also the fact that you can change your mind, like Python famously made breaking changes between version 2 and version 3. Yeah, well, we can all debate whether or not that was a good choice, but you can do that if you're the boss, because you can just say, this is what we do. Sorry, we messed up. And we've done this for Hedy as well.
Okay.
We split a level in 2 because we found that indentation is just really, really, really hard.
Yeah.
So we said, this is too hard. 2 is the first step. So we need to make something smaller. You can only indent one level. You cannot indent multiple levels initially. And then only in a later level you can do like nested indentation, because kids would do that unintentionally because they didn't know what they were doing, and then it does work, but they have no clue why it works. So this is the thing. I can just say, sorry, this is a bad choice, we will now do it differently. Nobody can stop me. Whereas, and there are proper arguments against breaking backwards compatibility, right? Oh, people already have their lesson plans made. This is not nice for kids. They log in today and then their programs from yesterday, they don't work. These are all valuable arguments. But this can take you forever to make such a decision. you can move quick and agile if you are the sole person making the decision. But it can
Exactly.
be psychologically quite heavy, because sometimes I make a decision. Yeah, so we had this with a contributor. I said,
Mm.
let's implement something in a certain way. So I made an issue report. I said, let's do this. And then a contributor actually did it exactly as I wanted, which is really nice. Sometimes people start arguing, but this is like one of my favorite contributors. He
Yeah.
just does what I want. So he does this. And then another contributor comes in and she says, well, actually, this new version of the framework, the partial framework, has a feature to do this. So we can delete all this work and
Yeah.
just do it slightly more efficient. So I was like to the first contributor, I'm sorry for throwing away your work, because we changed our minds on how to do something. He was very good sport about it. He's like, oh, I understand this is more elegant. But yeah, it does happen that I order something from the community, and then later on we have to throw away or change the code because, yeah, voortschrijdend inzicht, what you say in Dutch. We have new information.
Exactly. New
We
insights.
want to do stuff differently. Yeah, this happens.
Yeah. I mean, you're only human, right? And I think it's fine. Everyone makes mistakes. It's just learn from them and move forward. Basically, you can't be stuck with your mistakes and I don't know, let them take you down, I guess. I love the
Yeah, that's the other option, right? That's the
yeah.
yeah. So we made a mistake, and now we have to nurse the mistake forever.
I love the JavaScript example that you gave, because me, from a user perspective, I've seen some stuff and I don't know why, but to me it doesn't make sense, right? But now that you explain different people making different decisions, even maybe making mistakes, those end up in the language. And from a user perspective, you're going to see that, you're going to feel that, because you're the one that's using the language. This is just on a bigger scale. And eventually,
Yeah.
do you think Hedy will also reach that scale? Or if I phrase it differently, where do you see Hedy going from here?
Yeah, so I do think in the future it will be harder to make changes,
Yeah.
because more and more schools and more teachers are depending on Hedy to work the way it works.
Yeah.
And they start to create slides and lesson plans. So then if we do make changes, we know if it's small bug fixes, then they're happy. But indeed, if we end up overhauling our levels again,
Yeah.
I don't think we will do that now that we really have thousands of users. It was a bit easier to do a year ago. So I don't plan that, but then again, it is also research, right? If we do a study and we see that something isn't working well, it's sort of my moral responsibility to change. Like the localized keywords is a good example.
Yeah.
I didn't think it was necessary or useful in the beginning, especially for Dutch kids, because I thought Dutch teenagers, they know English, right?
Yeah.
Print is print. And echo is echo. There's no difference. It is easy. But then we do a user study. We ask kids, what is the most important thing we can change? And they say, we want to program in Dutch.
Really?
So I can say, everyone's surprised by this.
Yeah.
Everyone is surprised.
Yeah, same here.
So then, I can have an opinion, but I cannot argue with my test subjects, right?
Yeah.
If this is what these kids say, then, and this is also interesting because there might be some cultural sample as well. The school that I work in is very much a sort of an inner city, lower socioeconomic class, lots of kids that don't have Dutch even as their first language.
Okay. Yeah.
It's very, very well possible that the type of kids that we know and the type of kids we were when we were teenagers are very different than this specific demographic. So then that was a case where I thought, well, I personally do not see the value, but if this is what users need.
Yeah.
And of course, the interesting thing is once we build localized keywords for Dutch, then you can also do it for other languages. So now we also have Arabic keywords and we have Hindi keywords.
Yeah.
And you can see how in that context, there's no question whether that is useful, because people that grow up speaking Arabic as our first language, they don't even know what our letters are.
Yeah.
Right? A teacher cannot even explain print. It starts with P. What is a P? What
Exactly.
does that even mean?
What does it look like?
Where is
Yeah.
it staying on my keyboard? Right? How do I type the thing?
Yeah.
So the nice thing also, and this is very true in general, that if you make something inclusive for a certain category of kids, often a different category also benefits from that. But that's a clear example of something that Of course, I thought about it,
Yeah.
but this was way on the low end of my to-do list. Also because it was super hard to build and lots of work,
Yeah.
and it leads to all sorts of interesting side questions. But yeah, so sometimes you I think have to, or at least it's good for you to listen to what the community wants, even if these are things where you necessarily as a person yourself don't see the value.
Yeah. It probably says a lot about you as a person, but I'm very stubborn, right? I can be like, oh, I want this thing. And someone might disagree with me and I might still do it. Depends on the case, obviously. But you're very much open to feedback from the community, right? If it doesn't make sense to you, but that is what your users are saying, then obviously that should be the right choice. At least that's how I see it, depending on the context, depending on the thing.
It's not, so I said in the beginning of the episode, scratching my own itch. So I'm sort of like, I have to eat my own words.
Yeah.
So yes, it is scratching my own teaching itch, right?
Exactly.
I can already do programming. I already know Python and many other languages. So it is not a language for me to use as a user. It is a language for me to use in teaching.
Exactly.
So if this is what kids say makes it easier, then yeah, you do have to take it very seriously. You have to understand why, and then they do have good reasons, right? Because of course we didn't just say, like a menu, just tell us what to do and we will do it, like without thinking about it. Of course we ask them. And one of the things they say is that the keyword we have for asking something is ask. And ask is a hard word to get right in Dutch because we never have sk.
Yeah.
There are hardly any words in Dutch where there is sk. So they're like, yeah, but that's just, it's weird to say. It's hard to type. I would often type AKS, AX, because KS is something that occurs more often. So they're like, yes, this is sensible. Or they're not just saying a random thing.
Yeah.
And it's actually known from other research as well. We have the word for a loop, for I in range.
Yeah.
This wasn't even our study, but other people have already found that for is a really bad keyword because it sounds like for, the word for.
Exactly.
So kids would type for, and especially if your first example is making a square, then you have for I in range 4. You have 2 times 4, and they have spectacularly different spellings and meanings, and one is a 4 number and the other is a word for. So 4 is just a really, really bad word.
Yeah.
So yeah.
It makes sense. In the end, it makes sense, but it goes from being kind of your programming language, right? Really in kind of an incubation thing. You're trying out more things to, it's no longer yours. It's more the user's thing. And they're giving you feedback. This is how we want it. This is how we can best learn from it, basically.
Yes, for sure. And also it isn't always clear cut. Like we do debate this a lot in the team.
Yeah.
Who is our user? Is our user the student, or is our user the teacher? Yeah. Some features are more teacher features than they are user features. And also sometimes we get emails. Those emails are just a bit more frequent because those people maybe know better how to reach out. We get emails from parents.
Yeah.
Very often they are programming parents. Like, yeah, I'm doing this together with my son. Very often it's a son. And I just happened to notice this and this and this and this. And then they start trying full Python syntax in level 1, and it doesn't work. And they're like, yeah, but it should already support whole Python.
Yeah.
So there's really these different type of users. So even if you say it is a thing of users, I 100% agree with that. But it isn't even so easy to nail down who a user is.
Yeah.
And how to test it. And also the localized features, for example, I rarely test the website in Arabic because everything is right to left and I don't understand anything. Right? So it's just a thing that gets tested less.
Yeah.
I feel bad about this. Of course, we have automated tests, but sometimes you also want to see what it looks like. So there are just these parts of the language that get more love and more interest than other parts.
Yeah. Yeah, that makes sense in the end. Man, I love the journey you laid out. And I really feel kind of how that journey went in the learnings that you've had, how you started and how you got to the point where you are now. I think the future is very bright, but it has its own challenges, right? I think that's with any product that you'll build. But I love that you've really created a tool to teach kids to program, basically. That's exactly what you've done. That's exactly the problem you wanted to solve. In laying out that journey and the conversation we had, is there anything that's missing still? Anything you still want to share?
No, I think we really shared the biggest things. Maybe we want to share that we're always looking for help for contributors.
Yeah.
So maybe we can put the GitHub repository in the show notes. And also, we have a website. We use a framework called Weblate to translate.
Yeah.
So if you have teacher friends, they don't have to be programmers, that know a language that isn't in the list of 18 languages,
Yeah.
we also very, very welcome more translations in languages that we don't yet support. We are still missing some big languages. So if people want to help out, that would be very, very cool.
Yeah. We'll do everything possible to put that in the description. All the links to Felienne as well, Twitter handle, probably LinkedIn stuff as well. So you can reach out and see what you think about the language. Give us some feedback. I think that'd be awesome. And if you've made it this far into the show, give us a review, maybe on a podcast platform, or let us know in the comment section below on YouTube what you thought of this episode. And we'll see you in the next one then.
Beyond Coding. From your sponsors, Zebia, creating digital leaders.